And welcome to SP Live and today's broadcast, Transforming Stimulation Through Intervention. Joining me shortly is Pierre Ramondenc and Philippe Nkababayan from Schlumberger. We continue from SP Live yesterday on proactive intervention. We'll look at how best to optimize stimulation and conformance operations for improved production using fiber services, software integration, and other intervention services. My name is Nils Korksen-Love. It's my pleasure to be your host today. And if you're new to SP Live, check us out on social media, #SP Live, or find us on spe.org and check out on under SPE Live and live events. A lot of great content. Enjoy at your leisure, all for free. Now, let us meet our guest for today. Pierre Ramondenc, Coiled Tubing Technical Director, Reservoir Performance, Schlumberger. Pierre has more than 15 years of oil field experience. He is responsible for the definition and implementation of new workflows, both operational and software related. Also technical competency and training programs, tools, and overall digital architecture of coiled tubing services, and several production enhancement initiatives. Pierre has been involved in all aspects of coiled tubing real-time telemetry, including tool creation, intervention design and execution, and data interpretation. He has led the creation of the most coiled tubing intervention workflows that leverage real-time data, fiber optics, distributed sensing, and the inclusion in the production digital landscape. And joining him is Philippe Nkababayan, Middle East Stimulation Domain Advisor, Reservoir Performance, Schlumberger. Philippe is a Stimulation and Conformance Control Advisor for Schlumberger. He is currently in the Middle East Stimulation Domain Advisor based in Abu Dhabi. He is responsible for the deployment of stimulation technology to address the completion and production challenges of Middle East operations. Philippe's expertise has developed over a 26-year career with Schlumberger, within which he's held multiple technical and managerial roles. He joined Schlumberger back in 1994 in Algeria, performing well intervention and stimulation treatments. Since then, he has worked in continental Europe, North Sea, North America, and Southeast Asia, Russia, and the Middle East, so significant experience. Pierre, Philippe, welcome to SP Live. It's great to have you here today joining us, and thank you very much for making the time to join us.
Hello, Niels. Thank you for having us.
Thank you. Just a quick reminder to our audience, I'm fairly certain you all are eager to learn more and also share your opinions and questions around stimulation and how it can best be combined with intervention operations and technologies. So please share your thoughts on the social media chat, and we'll be picking up your questions and comments as we go. So thank you. I can already see you're very busy saying hello to us also. Please keep up the comments and questions. We'll be watching as we go. Now, Philippe, the floor is yours. Please take it away.
Very well. All right. So quite a lot of things have happened in the last few years in the area of stimulation. There's been a lot of new chemistries that have revolutionized the way we treat and we divert the treatments. There's been new chemistry in terms of retarded acid system that allow us to better create wormholes in carbonate reservoir at a multiple level of rates, whether we pump through coiled tubing or we bullet at high rate. These new fluids have allowed us to do things that we could not do with the previous generation of fluid. There's been a lot of new diverters that have come on the market based on viscoelastic surfactant, based on degradable material that are made into fibers or particulate. So there's been quite a lot of new chemistries that have revolutionized stimulation. At the same time, a lot of work has been done on the modeling side. We've improved our models. The computing power have allowed us to simulate things that would have taken hours or days of simulation in the past, and that now we can do in a matter of minutes. Integration of these models into the platforms that support our big 3D GNG systems allow us to interact directly with the data and the reservoir models that allow us to further model what the well is going to do after the stimulation. So there's been quite a lot of data integration and modeling optimization on the software side. However, despite these improvements, there's still quite a few treatments that do not deliver the expected results. We go with a target production or a target skin, and we find out that we have not achieved it. And when we look at the root causes for these issues, they tend to be revolving around our understanding of what really is happening downhole at the reservoir level, whether it is based on an incorrect reservoir characterization. The interpretation of the logs we had did not result on a true picture of what we were dealing with. Unexpected completion defect, whether it's the cement integrity or the isolation of the annular packer or the closure of a sleeve that we expected to be sealing, also lead to the fluid going in places where we don't want them to go. And that leads to the uncontrolled fluid placement. Obviously, if the treatments we pump do not go into the target zone, then the likelihood that we're going to create the stimulation we designed is less likely. Finally, understanding what's going on during the job is also important. We sometimes see behaviors at surface in terms of pressure that were not expected, and very often we have really no idea what is going on. I mean, we can make some guess during the operation, but surface data is not always useful to understand what is happening downhole. So when you look at all these issues related to the reservoir characterization, the integrity of the completion, the location of the fluids, as well as what is happening during the actual treatment, these are what we think are the main reasons why many treatments still do not deliver the expected results.
Thanks, Philippe. So you mentioned there root causes and understanding the subsurface and, for example, reservoir characteristics. So how can we de-risk treatments and increase stimulation effectiveness? Okay,
so it's actually the main theme of this whole presentation, and when we approached that with Pierre, we identified two main elements. The first one is more related to the treatment itself, and it's getting the fluids to go where we want them to go, in the volume we want them to go. I mean, obviously, we want an homogeneous distribution into the net pay that we want to stimulate. But as important, if not more important, is improving the downhole understanding. Understanding how the formation reacts to the fluids we are pumping, maybe how it reacts when we're doing an injection test, so that we can better interpret and confirm what we believed about the formation, and how it reacts during the treatment, as well as how it reacts after the treatment, after we stopped pumping. So improving the downhole understanding, as well as improving the stimulation fluid placement, is really where we think that intervention can really transform stimulation. And I'll leave it to Pierre to go on and speak a little more about the technology.
Please.
Yeah, thanks, Philippe, and thanks for stating very clearly which are the challenges the stimulation industry still today is facing. I think that, looking at all the challenges, the limitations, in fact, well intervention and the way that it has evolved has a lot to offer in terms of addressing all those different limitations. And if you will, it's in many ways it can enrich those stimulations further. When maybe 15, 20 years ago, a stimulation was about pumping from the surface of fluids. Nowadays, it's much more than this. We have much more activities around them. And a lot of the technology that has been developed on the well intervention side can actually provide avenues in coping with those demands. So you see here on this particular view, you have a typical spread at surface involving cold tubing, because cold tubing has historically been involved with stimulation work. But that being said, if we actually look back at one aspect that was discussed, especially yesterday by William Antonio and Matt Billingham, discussing the proactive intervention, you will realize that over the past 10 years, all those developments that have happened in the well intervention industry have created a breadth of portfolios that can really adjust to any type of environment, and that covers a full span of the different activities that you can do in a well. As a matter of fact, if you focus and if you check on the trend of the development over those past 10 years, you will realize that a lot has to do with gaining that finer and greater control that you need to have downhole to make a difference and to get that optimization you need during an operation. So the advance of things such as powered intervention, for instance, or on-demand actuation, even the access of telemetry and getting the data during an operation, which 10, 15 years ago was unheard of. It was all about getting the log before and after an operation. Nowadays, you get access of all this during an intervention. All these created a situation and an opportunity for optimization on the fly and changing a lot of things during the operation. And this is really where the opportunity resides today for the stimulation world. And the fact that because you have those capabilities through an entire portfolio, then you can pick and choose what is the best solution to your need and your limitations or constraints that you have downhole. So we can, obviously we could talk about all the different technologies, but I think one that is worth mentioning, because I guess for many in the industry, this is the one that really started changing the face of stimulation as we know it, was the introduction of fiber optic sensing. So when between 10 and 15 years ago, the first logs of distributed temperature sensing were obtained on fiber optics, I think, and Philippe can confirm this, it's really when we started changing stimulation as we know it. And the reason for this was that for the very first time, we had eyes downhole, the capability to actually seeing where the fluid was going as it was being pumped. And this was a real breakthrough, honestly, because all of a sudden you were able to confirm many things that you suspected, discover some that you were not suspecting, and by doing so you were able to adjust and as such optimize the operation to greatly increase your rate of success. And as a matter of fact, if we look, for instance, at matrix jobs, when in the past, in some projects, we had sometimes up to 60% of the operations that were not up to the expectations that an operator would like to have. Introduction of technologies such as this one totally changed the success rates, and today, a lot of those different operations yield expectations, or they yield a result that is beyond the expectations that was initially there. Now, the beauty of the situation in which we are today is that, as you can see, you can choose your convenience means. You're not stuck with having just a cold tubing on an operation. As a matter of fact, when the conditions are not prone to using cold tubing, you can move to having a slick line, you can use a wire line, and this is a full span of stimulation work, not only matrix, but also hydraulic fracturing, even conformance work. So this is, it's really this development of technology and the ways that having access to downhole information all of a sudden gave those insights to change entirely the way we were understanding and planning and executing the operation, which is something that can have a great impact and resonate very much in the stimulation world.
Thanks, Pierre. So you talked there about the technologies, and in particular how fiber optics have been a big step change in this technology revolution in helping us improve effectiveness of the operations. So I'm just going to pick up a question from Marcos Dominguez from the audience. So improving downhole understanding during the job is great, but without understanding the downhole environment before the job is very important. So question to the pair of you is, how do you put all this new technology in use for a better understanding of downhole conditions?
So,
excellent.
Philippe, I let you take a stab at it, and then I will pitch in.
Well, I mean, I think that ties to the section on formation and completion diagnosis. If you go to that section, and maybe we can go to that one. Yeah. So clearly that's an extremely good point. Understanding what's happening during the operation is important, but understanding what's happening before the operation is also very important. Why? Because what we're going to see before the operation is going to potentially help us redesign the operation and prevent some of the failures that would have resulted had we not understood the environment before the treatment. And then I'll just mention a few examples, and Pierre will go through some. Will add to my point and show you how that technology is utilized. But things like an unexpected thief zone is something that we have found more often than we expected when we started to do some actual measurements of injectivity using mostly temperature data. And as we know, a thief zone can have a drastic effect on the stimulation itself, because it will take most of the fluid. The tighter formation will not be stimulated, so you may get some good result when you open the well, but then it's going to collapse rapidly in terms of productivity. So understanding which are the zones that are going to take the most fluid and whether or not this is abnormal may allow us to redesign the diversion part of the treatment to make sure we have a more aggressive diversion. Now, if we find out that there is no thief zone and we expected one, then we may dial down the level of diversion that we wanted to do, or we may adjust the fluid quantity that we wanted to place. There's also the questions that I mentioned very quickly in the first slide of the completion integrity. Okay, we're going there assuming that we understand what is the cement integrity, what is whenever we have annular packer and sleeve, that they are either isolating or closed or open the way we expect them to be. So the ability to do a limited amount of operation prior to the job to confirm what we were expecting in terms of formation and completion is extremely important. And here, if you want to add something here and
yes, thanks, Philippe. I think that you summarized very well the type of things that definitely we would like to check before designing an operation. And you know, the different, we have a few examples here that we combine and we compiled. They are going to take us through some examples of the type of checks either before or during, even activities that are happening after an operation, so that overall we keep improving, you know, this return on investment that you get during a stimulation job. Now, the obvious thing is, as you said, Philippe, the very first thing and foremost for any stimulation work is to know whether you have some zones, one zone or several zones that are going to take most of the fluid that you're pumping. It's like the basic statement that if you're pumping something, you want it to go in a very specific place. This is how your design is made. If it's going in the wrong place, you totally miss the point. And on this screen, you have one of the very early examples of using distributed temperature sensing to get that analysis before starting an operation. Now, this example is nice for two reasons. The first one is that I think that it's so striking when you look at it that anyone can understand that if you plan an operation where you want to stimulate a bottom zone, then it's not going to happen. So the second nice thing about it, and it's a bit of a history, is that it was totally eye-opening to not only the service company performing the operation, but also the operator. Because, and that's one thing we didn't necessarily talk about initially, but a lot of the stimulation work that was done 10, 15 years ago was based on rule of thumb, or what was estimated to be the success of an operation, and success being improvement of production. Now, with this example, all of a sudden, it changed entirely the mindset and redefining the notion of success. Is the success improving my production based on my benchmark, or is it really maximizing my return on investment? And from the introduction of the notion of measurement, before performing that operation and fully understanding the formation, the completion, before executing that operation and refining the design was that insight that was missing to truly go to the next level. We also have, obviously, we have an analysis of different zones, but we could look at, for instance, the presence of fault and the presence of natural fractures. So Philippe can be a good witness of this. In the stimulation world, you always are afraid of undetected big things that you would have, and natural fractures, which tend to be difficult to detect, to characterize, are one of the big unknowns that you would have during a design phase, and after that for the execution of a treatment. Now, having all the different tools totally agnostic of which conveyance means you're using allows you having that characterization that is going to make the difference between performing an operation that may be okay in terms of the delivery and one that is really going to make a difference. And because we're talking about those conditions that have a high degree of uncertainty, especially in the design phase, if we look at, for instance, the completion that Philippe was talking about. So one of the aspects of the completion, whether this is the presence of maybe a casing leak, maybe that's the presence of a failure of one part of the completion, sleeves that wouldn't be holding, or in this particular case on the screen, what we have in terms of swell packers that would be holding and segregating in between the different zones. Those are the type of things that today we can analyze and that make a huge difference and are going to make or break an operation if we're capable of detecting them.
Thanks, Pierre. So we're picking up some great comments from the audience here. And so the pair of you have been talking now about the importance of data. So let me just bring in two questions from the audience. So first of all, Ahmed Tunublu, how do you design and execute the jobs if some or most of the reservoir data is missing? And so another aspect of data, again, Marcos Dominguez, thank you again. He's asking, okay, a lot of the reservoir knowledge prior to job is acquired in open hole. So, you know, how does that maybe conflict with what you're going to be doing in the stimulation operation itself? So it brings, I guess, trying to bring a question in here is, how does access to data enhance operational efficiency and help you improve the stimulation outcome? And, you know, when is missing, what do you do?
Okay. All right. So I like these two questions because in one case we don't have the data, in the other we have the data, and to go back to this formation diagnosis, if you don't have the data, the ability to go downhole, do an injection test, look at the injection profile, and derive the injectivity per zone allows you to create a data set that you can use to see if your design is adapted to that data set. If you find out a very homogeneous reservoir, then a certain level of diversion will be needed. If you have a thief zone, you can go more aggressive. Now, if you have the data and out of that data, you derive a permeability profile and you know which are the zones that are going to take more fluid than others, and you design your treatment, you still want to go down there, do an injectivity test, and confirm that your assumptions are correct. Because if they are correct, I mean, you've wasted half an hour and a little bit of water. If they are incorrect, then you really want to step back and look at your design. So in both cases, the ability to test before you do the job is important, and it's also important to validate your design assumption, which you derive from the data you have. And I'll just take two examples, and then I'll let Pierre continue on that. Very often we're given a bottom temperature, and in some cases it's a measured temperature. In other cases it's an estimated, and temperature can be very important in terms of corrosion, in terms of when we use degradable material, the time it's going to take to degrade is going to be very temperature dependent. If we use delayed cross-linked gel for water control, for example, these chemistries are very temperature dependent. And if we're too cold, the gel is not going to set. If we're too hot, it's going to set in the coil tubing, and then we have a fiasco on our hand. More often, actually, it's pressure that I find problematic, especially when you go into infill wells or very depleted wells. More often than not, the pressure is much, much lower than we expected. And with lower pressure comes all the additional complexity around setting inflatable packers, because we deal with differential pressure. U-tubing, when we place fluid with coil, the fluid may not go where we think it's going when we pass it over the gooseneck. And then we may find out that the well is not going to be able to flow back. And we need to think about, do we need to nitrify the fluid? Do we need to foam it? Do we need to get more nitrogen? So these are things that can help. And there are many other cases like that where the assumption that we have taken into our design are sometimes not correct. And having the ability to make a measurement prior to the treatment becomes very, very important. And Pierre, if you want to add something.
Thanks, Philippe. And I like the examples that you took in terms and the explanations that one of the very first things that we do, whether we don't know, or even if we know which are the downhole conditions, or we have a fairly good understanding of the wellbore and the formation, is always to check. There is one thing to understand is that even if you perform a log, even a few days before an operation, nothing guarantees that the downhole conditions are going to be exactly the same as those that you plan for while you're performing an operation. First off, because it may have evolved. The reservoir is dynamic, so it can be impacted by some other aspects, but it can be also from the standpoint of as simply as I am introducing, for instance, a coil or any other thing in the wellbore, and I'm totally changing the conditions. And this has, as Philippe mentioned, a great importance on our ability to properly deploy some mechanical isolation tools, such as inflatable packers. There is always a risk of designing for inflation at a certain depth, and it's kicking in higher up, and then we have troubles. obviously a huge impact on the flow, because as you know, with differences in pressure, you have the flow will simply go with the path of least resistance. So we always check the type of things. Now, I like the question about I do not have that data necessarily, and I think that it's maybe one aspect of the intervention world and how it's evolving currently that can be looked at and where it can help tremendously. If you remember towards the beginning when I was giving a little overview of how well intervention has evolved over the past 10, 15 years, one big key element that appeared was the access to data. And the access to data always in any operation where you would have the tools that have instrumentation, obviously. But by doing so, it means that whichever operation you're performing with those tools will gather the data and will give you insights on what's happening in that wellbore, in those wells. This information over time is going to be a great historian for you to plan those next operations or to get that additional information to bridge the gaps that you had on your understanding of a specific field or a specific wellbore. So it's not only from the standpoint of getting the information right before performing the job because you have the equipment or during the operation, but over time you have that historian being built up and that information through interventions that sometimes have nothing to do with stimulation, but are going to give you that edge to perform better on the stimulation. Now, just to give a few examples, because we were talking about it, this is one of those cases that a field was requiring some abandonment and trying to have a rejuvenation. The big question was, okay, but how do I do that at the level of a campaign? How do I get that data to truly know where I need to abandon the interval? Do I have bypassed hydrocarbon? And this was done through a development of being able to log with logging tools, typical logging tools, but on a piggyback of a well intervention, things that maybe 5-10 years ago wouldn't have been possible, but that was possible through an introduction of the technology. Another great example to what Philippe was discussing is that especially for anything that has to do with conformance, so water shutoff or gas shutoff, very often those fluids are designed so that they start setting at a specific or within a specific range of pressure and more than that temperature. Now, obviously, knowing the exact temperature in front of the interval where you want that activation to happen is something that needs to be very accurate and that is extremely hard to get, even though you have a record of operations maybe a week before. And that's where having access to the downhole information of pressure, temperature during an intervention and while you're pumping in the well is changing entirely the approach. And especially for those polymer foam systems, such as one example we have here on the screen, it meant bringing a success ratio of about 50% to something that was close to 95%. By just getting access to that type of log, which tells you as you're pumping in the well, how the temperature at the bottom is evolving so that on the fly, you can choose which curve and which amount of additive to put. So those are great examples of something that may seem simple in terms of data access, but which makes a big difference. And once again, it's enabled by intervention means.
Thank you, Pierre. So a lot of great comments there. So I'm picking up, you talked there about the importance of historic data, and because we're dealing with a dynamic reservoir condition, we always assume or a lot of people assume it's static, and that we are interacting with the reservoir throughout various operations. So the criticality of data is always present. So I'm thinking now sort of key takeaways for the audience, and also, you know, are the improvements that you've been talking about for stimulation through intervention, are they really focused around the execution of separate treatments, or can we learn a lot from accumulation of data and knowledge and experience?
Okay. All right. So I'll make a first attempt. The importance of data is not only limited to the treatment that we're using the measurement on, whether it's in assessing the efficiency of diversion, or looking at the kind of volumes and skins associated with these acid volumes in different types of formation by doing a post-job measurement. These are all data that can be used to refine the designs and completely change the stimulation strategy for the future wells. So the value of the data is not only in the well we apply it to, but in the future wells. And Pierre mentioned about doing the value of temperature measurement for water control a few minutes ago. So that is really one of the key takeaway. The data is not valuable just on the well you apply it, but on the whole wells that you're going to do in the future.
To complement what Philippe is saying is that you obviously need to take into account the different time horizons of the use of that data, but also the access of how you're using that data in the short frame and in the short time frame and in the longer time frame. Having, for instance, a comparison between pre-stimulation, post-stimulation was the old approach, extremely valuable in terms of learning what worked well, was that a good improvement, and in a way to be able to quantify what was the success of that particular approach. Today, with the introduction of all those measurements we have during the operation, we can contextualize this, and we can actually make the link in between what's happening during the operation, what is the outcome, and we can reach that level of quantification of the success, no matter which way you want to look at it. Is that from obviously improvement of production or reduction of water and gas, unwanted water and unwanted gas production, or is it from the standpoint of being able to pump a fluid in one zone? Now, all this, and because of all the new digital capabilities we have today, we haven't talked that much about that aspect of things, but we can ingest that data back, and we can start making fast comparison and extraction of what worked well, what works the best for certain type of conditions, and what doesn't work well for other types. And as I said, when you put that back within the context of what has been the history of interventions in one well or on one field, and you take all that data in, then all of a sudden you realize that you can all of a sudden customize a stimulation strategy nearly on a well basis or on a field basis, which is certainly the difference compared to the old rule of thumb approach, which was like categorizing big chunks or with big problems. Now it can be truly customized to the level that today you can actually define some very neat workflows that are fully leveraging the full scope of what you would have in the wellbore, especially with intervention means. I said something at the beginning, which was that stimulation today is not as much just pumping a fluid from surface anymore. It's not that. What's changed in getting access to the data and being able to look at it from a higher standpoint in between wells and understanding much better, making that relationship in between what happens and the outcome, is that we started devising some workflows much more complicated, where a stimulation operation would actually involve some perforating, some isolation, some pumping of different types of chemicals, all in just one single run or one single operation. And today, very often, we have a complement of the well intervention activities, core activities, within those stimulation operations that are really bringing stimulation in a totally different realms of effectiveness and efficiency to the levels that, for instance, an operation such as the ones that we have here on the screen is something that with traditional means wouldn't have been possible. Simply, it was not economically viable for the operator to stimulate a specific well, open new intervals without losing the well, without having all the deferred production or even maintaining the well in production. And the key enabler to this was that capability by well intervention to perform those different activities within just one run and enabling the stimulation. So I think this is really the main takeaway, is that you have access to the data, but today we are beyond this. We are at the level of using the data in real time, but also outside of that real time small loop in that continuous improvement of the methodology and the workflow for the stimulation. And this is really what is delivering outperformance on the stimulation, no matter what it is, whether you're looking at hydraulic fracturing, matrix stimulation, or conformance, and taking into consideration the fact that we have more and more mature fields. You can feel how the importance is of all this, because simply it's going to be a big part of our future.
Pierre, thank you. That was an excellent summary there, sort of that opportunity that is now available to everybody in being able to not only acquire this data in real time through intervention operations to improve stimulation design, but also to then accumulate the data historically to help continue build an experience base and a knowledge base. So thank you very much. Pierre, Philippe, thank you very much for sharing all your thoughts and ideas today. It's been an excellent discussion on transforming stimulation through intervention. So thank you very much for joining us today.
Thank you, Niels. Thank you, everyone.
Thank you. And thank you, audience. You have been marvelous today. So thank you for all your comments and questions as we've gone along. We've been watching them, so thank you. We've been trying to get through all your questions. Unfortunately, we didn't get to all of them, but thank you anyway very much. It's really great to see you all engaging with us here on SPE Live. We've had a great week on SPE Live, full of tech talks around the topic of well intervention. So please look back, check these out from the week. Some really, really good content here. That's it from me today. Thank you very much for joining us, and see you all soon on SPE Live. Thank you. Have a great day.